Chapter 3, Section 2, Perception. What determines how I perceive my world? The principles of perceptual organization are looked at in figure and ground. When faced with complex stimuli, perceptual systems automatically pick out certain features, objects, or sounds to emphasize. Figure is the emphasized features, and ground is the less meaningful background. Reversible figures show that our perceptual systems are actively organizing stimuli. If you look at the three examples, what do you see? Grouping occurs as certain properties of stimuli lead you to group them together, more or less automatically. Gestalt psychologists argue that people perceive sights and sounds as organized wholes that are more than just the sum of their parts. Their principles that describe how grouping occurs are proximity, similarity, continuity, closure, texture, simplicity, common fate, synchrony, common region, and connectedness. Here's an example of 6 of them. Proximity. Objects that are close to each other tend to be grouped together. Similarity. Similar things are perceived to belong to a group. Continuity. Sensations that appear to create a continuous form are perceived as belonging together. Closure. People tend to fill in missing information to complete an object. Common region. Elements located within some boundary tend to be grouped together. And connectedness. Stimuli that are connected by other elements tend to be grouped together. Perception of depth and distance. Depth perception is the ability to perceive distance. Depth perception relies partly on stimulus cues provided by the environment and partly on the properties of our visual system. Stimulus cues are interposition. The closer objects blocks the view of distant objects. Relative size. If two objects are the same size, the object protruding a larger retinal image is perceived as closer than the one producing a smaller image. Height in the visual field. More distant objects tend to be higher in the visual field. Linear perspective. As two lines come closer together, the perceived distance increases. Reduced clarity. Greater distances usually yield less clarity. Light and shadow. Shading helps contribute to perception of 3 dimensions. And textural gradient. Texture appears finer, less detailed, with increased distance. The cues based on properties of the visual system are in accommodation. Muscles alter the shape of the lens to focus objects from different depths. Feedback, accommodation cues about this muscle activity gives the brain information about an object's distance. Each eyeball rotates inwardly or converges so that an object's image projects onto each retina. The greater the inward rotation, the closer the object. Thus, feedback from muscles that move the eyeballs gives information about an object's distance. The two eyeballs are in slightly different locations, so they receive slightly different images of the same object. The brain can use this difference between the two retinal images, called binocular disparity, to calculate an object's distance as well as its depth, height, and width. Motion. Optical flow is changes in retinal images across the visual field that provides cues about motion. Looming is a rapid expansion in the image size of an object so that it fills the retina. The image is automatically perceived as an approaching stimulus, not an expanding object. When you are moving, the flow of visual information across the retina combines with information from the vestibular and touch senses to give you the experience of motion. If the visual flow is perceived without appropriate sensations from other parts of the body, motion sickness may result. Stroboscopic motion occurs because we tend to perceive movement when a series of still images appears one at a time in rapid succession. Size illusions. Illusions are perceptual mistakes, inaccurate interpretations of sensations. Size illusions are illusions of the visual system. They reflect our perceptual system's attempt to process information that violates one or more of the perceptual principles. How do I recognize familiar people? Your brain analyzes incoming patterns of information and compares those patterns to information stored in memory. If it finds a match, recognition takes place. Two general processes occur in recognition. Bottom-up processing relies on specific, detailed information from sensations. This information is analyzed by certain sensory feature detector cells into basic features which are then recombined to create perceptual experience. Top-down processing involves the imposition of higher-level mental processes, experience, context, expectations, and motivation onto an incoming stimulus, actively constructing a perception based on more than just the raw stimulus. Previous experiences help create schemas, mental representations of what we know and expect about the world. Schemas can guide or bias perception by creating a perceptual set, a readiness to perceive a stimulus in a certain way. In a tense, potentially violent situation, someone reaching for a cell phone may be perceived as reaching for a gun. Context can affect expectations and thus perception. For example, it may be easier to recognize your bank teller in the bank than when you're at the grocery store. Motivation also affects perception. For example, a hungry person might initially mistake a sign for Burger's Body Shop as indicating a place to eat rather than a car body repair shop. Both top-down and bottom-up processing work together. For example, in reading a word, the visual shape of the letters must be sensed, bottom-up processing, but a person uses knowledge, context, and expectancy to figure out the meaning of poorly written letters, top-down processing. Top-down processing can fill in the gaps between stimuli because the stimulus world is redundant. It provides multiple clues about what is going on. Can you run out of attention? Attention is the process of directing and focusing certain psychological resources to enhance perception, performance, and mental experience. It helps direct sensation and perception, select information for further processing, allocate mental energy to do that processing and analysis, and regulate the flow of mental resources necessary for performing a task or coordinating several tasks at once. 3 important characteristics of attention are it improves mental processing, attention takes effort, and it is limited. Directing attention. Overt orienting is shifting attention by physically pointing sensory systems directly onto the attended stimulus, such as when you move your eyes onto something you are viewing. Covert orienting is shifting attention without making a physical effort, such as when you think about something without directly seeing it. As overt and covert orienting suggests, attention control can be voluntary, goal-directed and purposeful, or involuntary, stimulus-driven. Attention is selective, focusing on some stimuli more than others. Inattentional blindness occurs when you are so focused on one aspect of the environment that you fail to perceive changes in other parts of the environment. Parallel processing is the ability to search rapidly for targets in several locations at once. This early feature analysis is automatic, not requiring volitional effort, and allows quick pop-out of relevant stimuli. Dividing attention. Divided attention occurs when you are simultaneously devote mental resources to more than one thing. Since attention is limited, it can only be divided to a certain point. Sometimes it is difficult to focus attention on only one thing. For example, in the Stroop task, it is difficult to ignore the meaning of the word and only pay attention to the color of the ink it is printed on. And that will be on the next slide. If one task is automatic, it requires less attention, thus making it easier to attend to a second task. It may be possible to perform two tasks requiring attention simultaneously as long as each taps into different kinds of attention. And let's try the Stroop test. Look at each word and speak out the colors, not the word. How did you do? This is known as the color word test. This chart tests the associations between color and language. The brain tries to identify the colors while another part of your brain reads the word. This regional brain conflict can produce errors in perception. Let's take a look at this picture. Does Lincoln's face look normal? How about now? This is called a processing illusion. Some neurons in the brain seem specialized in processing faces. Faces are usually seen upright. When presented upside down, the brain no longer recognizes a picture of a face as a face, but rather as an object. Will this man fall into the crevasse? This image is known as a trompe-l'oeil painting, creating the illusion of depth based on the principles of perspective. You must have a knowledge of reality to prove something is an illusion. What if we only ever see the illusion? Are the green squares the same color? Simultaneous contrast refers to the way in which two different colors affect each other. One color can change the tone and hue of another when placed side by side. The colors themselves don't change, but we see them as altered. The green squares are the same, but because of their context, they appear to intensify and diminish because of the surrounding colors. One color looks like 2, and 2 colors look like 1. The background color subtracts itself from the color it surrounds, causing the surrounded color to appear lighter or darker, and sometimes changing the appearance of a hue. In the first example, the small blue squares the small blue circles are the same color, but in the second example, they are actually 2 different shades of purple.
I want to start with a game, okay? And to win this game, all you have to do is see the reality that's in front of you as it really is, all right? So we have 2 panels here.
And we'll actually watch this TED Talk in class.